Okay, so in this video we will look at other types of electrical tests that we perform on the electric materials. So besides tan delta test, insulation resistance test, partial discharge test, these are some of the tests that we perform usually at the laboratory. Okay. Um, so we have more than this. There are other types of electrical tests, but we will cover only four of these. All right. um, Salt fog test, the tracking test, HVAC dry and wet withstand, and then dry and wet withstand using impulse as well. All right. So let's look at the first electrical test, which we call salt fog test. Okay, so this is basically the setup or the arrangement for the salt fog test. Okay, we have the sample in the middle. This is the dielectric material or the insulation that we want to test on, right? And you can see here we have a nozzle, spray nozzle to give salt fog, to supply salt fog within this chamber. Okay, you can see this chamber here. So the insulation is kept inside the chamber, and then the nozzle will supply that salt fog, will give that salt fog. And then we have high voltage supply connecting to the electrode here, and then this electrode will go to the ground. Okay, let's look at the actual picture of the salt fog test. Okay, HVAC salt fog test. You can see here that the supply injected is a high voltage AC supply. Okay, same thing, we have transformer here to supply that HVAC, and then connected to the electrode here, and then we have the test sample or the electric material that we want to test, and then we have the electrode here on the other side connected to the ground. And you can see here the hose that will spray that salt fog condition. Right, let's look at the uh, description or the details of the salt fog test. Okay, so as I said, salt fog was generated by nozzles. Okay, so we have nozzles located inside the chamber. Okay, so we have salt water that is being pumped by, and then with the air compressor to spray that, to make that salt water become fog. And you can see here the test object placed horizontally on vertical blocks in the chamber between the earth frame and the bushing. Okay, so we earth frame is connected to the earth, and then bushing connected to the HV supply. Okay, so basically we have two electrodes here. Two electrodes, one is connected to the supply. Okay, two electrodes, two ends of electrodes were applied to the two ends of the sample. Okay, we have two ends of the sample which are the electrodes, and then one is connected to the high voltage, one is connected to the ground. Right. So the high voltage was supplied to the conductor from an HVAC transformer set located outside the chamber. Of course, the transformer must be outside the chamber because inside the chamber it has fog environment, right? So the transformer is outside the chamber, and then we have a ballast current limiting water-based resistor, basically a resistor. Okay, resistor for current limiting. Okay, you can just memorize it as current limiting resistor of 1 mega ohm. Okay, we use 1 mega ohm current limiting resistor which is located here. You can see here we have HV supply, and then before we connect it to the sample, we have current limiting resistor 1 mega ohm. Of course, we put resistor to limit the current, to reduce the current. Okay, because what we are doing here is we want to uh, supply the high voltage. So if there is a case of flashover, then we want to limit that current. So the tests were conducted by applying the HVAC voltage, alright, high voltage AC supply. Value and duration of the voltage depends on the test method. Test method means it depends on the standard. We have to refer to the standard. What is the how long is the duration of the test? What is the value of the high voltage to inject on the sample? We have to refer to the standard, ASTM standard, for example, IEC standard, for example. To the so the supply connected, supplying to the specimen, uh, that being sprayed continuously with controlled volume sulfur. So even the volume of salt fog must be controlled. So we have to refer that to the standard. So you can see here. So we have that current limiting resistor. Okay, to limit the current. Okay, and then the ground side. Okay, this one connected to the ground. We have current measurement resistor. Okay, to measure the current. Okay, basically to measure the current using resistor, right? And then we have data acquisition to measure, to capture the data. All right, and then of course we have computer, to view the waveform, to view the value of the current and so on, and then voltage as well. Okay, you can see here voltage probe also connected to the data acquisition. So you can measure voltage, you can measure current as well. All right, so the circuit may also have additional protection scheme in practice, in place in case of emergency. um, and then data are collected as voltage and leakage current measurement. So we measure the leakage current, how much the current leak to the ground here, using that current measurement resistor. And then we have voltage probe here, and also besides measuring the voltage and the leakage current, if there is damage on the sample, we have to make observation. Okay, we have to report on the damage. And then as optional, the test may be conducted for a long duration up to 1000 hours or more with the combination of UV lights. Okay, this is optional. You can expose the test sample with UV lights, to represent the real outdoor condition. Okay, because the idea of salt fog test is we want to test the insulation that will be used, uh, as insulation in a high voltage system. Insulation in high voltage system. All right, uh, such as insulator. All right, insulator in the overhead line. All right, so this the electric material exposed outside with UV lights comes from the sunlight. Also, specifically exposed to the environment if the insulator is placed near to the sea. All right, where it will be continuously exposed by the salt fog comes from the sea. So that's why we want to test if the insulation able to withstand this condition. All right, we want to simulate the condition of real environment. Okay,